Hi everyone, welcome to another practice problem walkthrough by physacademy.com. In this video, we are talking about the electric potential energy and how to use it when it pushes a charged particle to move. In short, we want to see how electric potential energy turns into kinetic energy. Let's read the problem statement and analyze it together. Proton beam therapy involves firing high-energy protons at a tumor. A proton beam means a few or several protons together in a group. The protons burrow into the tumor, coming to rest. This means all their kinetic energy turns to heat and gets transferred to the tumor. The kinetic energy lost by the protons goes into the tumor, bursting its DNA, thus killing its cells. In one case, 0.1 joules of proton energy is desired to be deposited in a tumor. So, the total energy of the beam is given, and we know the system's total energy remains the same throughout the experiment. The protons are accelerated from rest through a 10 megavolt potential difference to create a proton beam. It means, at the initial state, the kinetic energy is 0, and the delta V or the electric field's magnitude is 10 megavolts. By multiplying this electric field by the total charge of the proton beam, we can calculate the total energy. Remember, the total energy is already given, so we will work through this backward to find the number of protons in the beam. Part A. What is the total charge of the protons that must be fired at the tumor to deposit the required energy? Part B. How many protons is this? Part C. How many watts is this if the beam is only on for 250 microseconds? This short animation summarizes the stages of the experiment. First, the proton beam, in red on the left, starts from rest and accelerates, then collides with the tumor and eventually comes to rest again. We know the total energy of the beam is 0.1 joules, and at the initial state, kinetic energy is 0, therefore, the total energy is the same as the electric potential energy. Let's write this down in a mathematical format. On the left-hand side, we know electric potential energy is the total charge times the applied electric potential. The right-hand side is just the total energy or 0.1 joules. After rearranging the equation, we can calculate the total charge of the beam, which is 10 to the power of -8 coulombs. To calculate the total number of protons in the beam, we divide the total charge of the beam by the standard charge of one proton. After a short calculation, we get 6.25 times 10 to the power of 10 protons. To calculate the beam's power, we divide the total transfer energy by the time it takes to transfer it. After dividing 0.1 joules by 250 microseconds, we get 400 joules per second, or in short, watts. Thank you very much for watching this video. Please check our website, physacademy.com, or our YouTube channel for more practice problems. If you found it helpful, to support our work, please consider subscribing to our channel.